Across modern households, electronic devices enter and exit daily life at a steady pace. Phones, laptops, power tools, and household equipment are purchased, used, replaced, and discarded in cycles that appear routine. From the outside, this pattern looks like the natural result of technological progress or wear over time. But when examined at a systems level, the repetition becomes more visible. Devices often leave use not because their core functions fail, but because one supporting component no longer performs as expected. The device, as a whole, becomes categorized as unusable, even when most of its internal systems remain intact. This process repeats across categories, brands, and price points. The result is a continuous flow of electronics moving from homes into storage, resale, recycling, or disposal, often earlier than their technical lifespan would suggest. When devices stop functioning reliably, most responses follow familiar paths. Some users attempt basic troubleshooting, recharging, resetting, or replacing external accessories. Others seek professional repair services, only to encounter costs that rival replacement prices. In many cases, replacement becomes the default response. New devices are easier to obtain than repairs are to evaluate. Retail systems are optimized for acquisition, not continuation. Even when a repair is theoretically possible, the effort required to identify, diagnose, and resolve a single point of failure often outweighs perceived value. These attempts are not ineffective because of individual decisions, but because they occur within a structure that limits visibility into alternatives. The repeating cycle is sustained by several structural constraints. Devices are designed as integrated systems, where the failure of one component affects access to the whole. Diagnostic information is rarely surfaced to users in a meaningful way. Support pathways emphasize replacement rather than restoration. Battery systems, in particular, operate within narrow performance thresholds. Their degradation is gradual, but interpreted as sudden. Once a device fails to hold charge or power reliably, its operational status shifts from functional to non-functional, despite unchanged performance elsewhere. This framing creates a binary outcome: working or discarded. The absence of recognized intermediate states reinforces the loop. Outside consumer-facing environments, alternative formats do exist. Industrial, medical, and infrastructure systems often rely on maintenance models rather than replacement cycles. Components are assessed, restored, or reconditioned when feasible, extending system lifespan through continuity rather than renewal. These approaches are not framed as exceptional, they're embedded into operational design. The contrast highlights that the consumer electronics cycle is not universal, but contextual. The gap lies not in technical impossibility, but in how options are presented, supported, and normalized. Within this context, some resources have emerged that document methods used in non-consumer environments and translate them into accessible formats. These materials do not function as devices themselves, nor do they replace existing products. Instead, they exist as structured compilations of processes that address specific points of failure within the larger system. Their role is not to override the market, but to occupy a space the market does not prioritize: continuity between use and disposal. Whether or not individuals engage with such resources depends on their willingness to operate outside default pathways. Their existence alone indicates that the repeating cycle is not closed by necessity, but by convention. When viewed in isolation, each discarded device appears incidental. When viewed collectively, the pattern becomes systemic. The same conditions repeat: partial failure, limited visibility, constrained options, and eventual replacement. Understanding this does not require immediate action or adoption of alternatives. It requires recognizing that the cycle persists because it is reinforced at every level: design, distribution, support, and expectation. A system that repeats itself does not do so because it cannot change, but because nothing interrupts it. Whether interruption occurs is not a question of urgency, but of awareness.